Now that we have a solution, so in the beginning, I had a mixture in which there were two solid things. And one example I gave was sand and salt. These are basically representing two things. One is insoluble and one is soluble. It doesn't have to be sand and salt every time. Mind you, it will be two solids. One is soluble, one is insoluble, and that's what's important. What do? We take a container in which we have a solvent and we put those things in there. One will dissolve because we have a glass rod to stir it. One will dissolve, one will not. Okay, so now we have a mixture in which we have a solution and we have a precipitate, something that doesn't dissolve. Okay, so we have a solution, things that are dissolved together, and a precipitate, a solid that does not dissolve. Okay, so we have done dissolving. Now we'll do filtering or filtration. Filtration hoti kya hai? Filtration depends on particle size. We know that the precipitate is a larger particle and the solution has smaller particles. So we get a barrier. Usually it is a filter paper. So this is your filter paper or any filter that you use. It doesn't have to be filter paper. Sometimes we use metal mesh as well. And you have a funnel. And then you take a container in which you're going to get the filtered parts. Now we'll take this thing and we'll pour it here. Now the solid that does not dissolve, it will be collected here. This is our precipitate now. Okay, so the precipitate here is basically collected over here. And the other thing will simply be collected here. Now, to show that we have already done filtration on it, we have new names for them. So this thing is called residue. When you hear the term residue, you already know that it has been filtered. And this is your solution, but we will call it filtrate. Very good, Amna. So the filtrate is basically telling me that this thing has already been filtered. There is no insoluble thing in it. Okay. Now the residue will be wet, right? And the next step is always how you collect it. Because remember, separation is incomplete if you're unable to collect those things. Separate करके रख तो नहीं देना. उनको collect भी तो करना है, extract भी तो करना है. तो extraction के लिए you will have to choose what you want. Do you want to extract the residue or do you want to extract the filtrate? Okay, so let's see. If I want to collect the residue, then residue is basically a solid that might be a little wet. So what do? So to collect it, to extract it, we dry the residue. And just to ensure that no soluble impurity is there, we will wash it. So we wash with distilled water. Can anybody tell me if distilled water is always? In what cases can we not wash with distilled water? Actually, this whole process is for a pure sample. लेकिन imagine आपका solvent था petrol, तो आप पानी से तो नहीं धोएंगे उसे. You will wash it with petrol then. It depends on the solvent you're using. If you're using water, you will use water to wash it. And of course, you will only use it if you're using water as a solvent. Then just a little change in the term. Solvent is never soluble or insoluble. Things are soluble in the solvent. So if your residue is insoluble in water, then obviously we are using water as a solvent. Okay, so we wash it with distilled water only if you're using water as a solution, solvent. If you're using alcohol, you'll say wash with alcohol. If you're using propanone, you'll say wash with propanone. And then dry the residue. How many ways of drying it? You can dry it in folds of filter paper. You can dry it in oven. You can dry it in sunlight. Somebody had a question. If you have a question, feel free to unmute yourselves. So dry the residue in folds of filter paper. That's what you can write. You can say that dry it in oven, dry it in sunlight. देखें, आपने जब भी काम करना है sensible होके करना है ना. What if you have something that breaks down in sunlight? Then you will not dry it in sunlight. What if you have something that catches on fire if it's in an oven? So you will say dry in folds of filter paper. Obviously, I'm going a little extra now because आपके exam में तो obviously वो इस तरह की बातें नहीं करते आपसे. So we'll simply say dry in folds of filter paper or dry in an oven. What if I want to collect the filtrate? And filtrate, as you know, it's made from two solids. One solid and a solvent. So एक solvent है, एक solid है. मुझे उन दोनों को अलग करना है. Or I can say, instead of writing solid, I can say solute and solvent. Remember, we started when we had a soluble thing. So to collect that solute, there are two ways. It depends on how the examiner has phrased their question. Sometimes the examiner says, collect pure sample of that solute. And sometimes the examiner says, pure dry crystals of the solute. So that term crystals is important. Okay. So two ways of collecting it. One is evaporation and one is crystallization. Good. So evaporation is you take the whatever solvent you have, you put it in a container that has a high surface area. Kyun? Evaporation happens from the surface. So you study this in physics as well. The higher the surface area, the easier it is. When we wash clothes, we spread them out on clothing lines because we want the surface area to be maximum. Right? When people cook rice, they do that in a container that has a wider mouth because they want water to evaporate once it has been cooked or something. So having a larger surface area is important. So you evaporate it. अब evaporate करने के लिए यहाँ से heat देनी होगी. अगर आप यहाँ से heat नहीं दे रहे, आप sunlight से heat देंगे. So two sources of heat. But the source of heat is important. What sources of heat do we have? So there's obviously the sun. There's a Bunsen burner or any fuel burner. There is electric heater. Now, there are other sources as well. For example, water bath is something that is commonly used. Sand bath used to be used. We don't use it anymore. So water bath and these four sources, you need to know where to use them. And obviously you just have to write about it. So if you're using Bunsen burner, then the thing must be non-flammable. So remember that alcohol is flammable. Okay. We use these when we have flammable substances. And sunlight is only used when you have things that are that do not break down in sunlight. So unaffected by ultraviolet light. If that happens, for example, if you have chlorine or silver chloride or something in mixture of chlorine, you will not use sunlight. You will use the other sources. So 4 sources of heat, and you have to remember what to use. So for example, if I have water and I want to burn it, I want to evaporate water and salt, I will make sure that I use any of these. Obviously, sunlight is a slower source than the others. If I have something else like alcohol, I will not do that. So what will we write in the exam? We write that evaporate. So if I want to get pure dry sample, if that is the question, I will say heat to constant mass when I do evaporation, okay? Heat to constant mass. But if I want pure dry crystals, then I will write heat to saturation point and crystallize, or cool. What does constant mass means? So here's the thing. Let's suppose I have this in an evaporating dish and I heat it. The solvent is going to evaporate. And once it evaporates, some salt is going to be left over. मुझे sides पे नजर आना शुरू हो जाएगा. I keep doing it. The thing keeps evaporating. Its mass will be reduced. As more and more solvent evaporates, mass कम होता जाएगा. एक टाइम आएगा कि सारे का सारा solvent has evaporated. I don't have any solvent left. That is the situation in which the thing has reached saturation point or crystallization point. Now, I don't see any solvent, but the solvent will still be there. For example, if I'm heating salt, the salt, let's suppose I have copper 2 sulfate. Copper 2 sulfate mixture is blue in color. So the water keeps on evaporating, its mass will be reduced. If you use a balance, you will see the mass value will be reduced. But after a while, you will see just blue crystals there. They are blue because they have water of crystallization in them. And crystallization is only possible because you have water of crystallization. Now, if I still heat it, what will happen? That water of crystallization is also going to evaporate. So I start with copper sulfate solution, which I write as AQ, and it has 5 water molecules attached to it. I heat it, it will convert to copper sulfate with 5 water molecules. And if all the water has evaporated, it will be solid. It will be blue in color. And this is what I call heat to saturation point and cool. But अगर मुझे इससे भी ज़्यादा cool करना है, मुझे इसे pure dry sample करना है, तो मुझे further heat करूँगा. And that way I will get copper 2 sulfate solid. This water of crystallization, it will also evaporate. And this is white in color. So if you go all the way, that is pure dry sample. If you don't go all the way, if you just stop here, you have gotten pure dry crystals. So that is how things heat, or that is how things eventually dry. So you have to take care as to what the examiner is asking. अगर उसने आपसे कहा है ना, so अब एक दफा दोबारा इसको देखते हैं. उसने आपसे कहा है, you have a mixture of sand and salt, find pure dry crystals of salt. तो आप क्या करोगे? सबसे पहले you pick a solvent, water, dissolve it. हो गया dissolve, stir कर लिया. Then filter it. You've gotten a filtrate. And we are not going to be bothered with the residue anymore. हमें residue चाहिए ही नहीं है. हमें तो salt चाहिए था ना. That is in the filtrate. Then I'll say, because I want pure dry crystals, remember, pure dry crystals. So I'll say heat to saturation point and cool. And that means we are going to stop here at the level when we still have water of crystallization. But let's suppose the examiner says, we want to collect pure dry sample of this salt. Then we'll rewrite this. Dissolve it in a solvent. Okay, good. Filter it. Okay, good. Then heat to constant mass. क्यों? मुझे pure dry sample चाहिए. मुझे water crystallization भी नहीं चाहिए. So that's the only difference in crystallization and evaporation. Evaporation goes all the way if you want pure dry sample, and it's stopped and you start to cool at saturation point अगर आपको crystallize करना है. Does everybody understand this? Any questions on how filtration and this whole technique is used? Okay, great. So here's your homework for today. You are provided with a sample of silver chloride, which is solid, and a sample of calcium chloride, which is solid. And you know that this is soluble and this is insoluble. It's a 5-mark question. Write down, it will be a 6-mark question. 6-mark question, write down the ways to collect pure dry sample of both of them. I will post it on Google Classroom as well. All right. If you don't have any questions, I will start with the next method. So the next method is that I want to discuss. That is, what do we do if we want to separate stuff based on the density? If you're not added in the classroom, go to the WhatsApp group. There's a link in the details of that group or something. Just click on the top of that group. Yeah. What is separating funnel? Separating funnel is basically a method that we use when you want to separate stuff that are, number one, they have a difference in density, and second, they are solutions. They are liquids or the gases. They are not solids, because separating funnel won't do that. So separating funnel is basically something that is shaped in a way that it is narrow at the bottom. So it is narrow here or something like that. I'm bad at drawing stuff. And you have a tap at the bottom and you just mix it up. So what happens is that because there's a difference in density, you will have multiple layers of these liquids. So let's suppose I have 3 liquids and there's liquid 1, liquid 2, and liquid 3. They have made these layers. So first thing you need to do is let it settle. And once it does that, you put a beaker here and you open the tap. This liquid is going to come down and you're going to collect it, but you're going to stop the moment these things come down and you have almost separated all of the liquid 1. Notice that some of the liquid 1 is still in there. So this will be wasted. So you collect just before all the liquid runs out, separate it, then waste that one. Then do the same process with liquid 2. Do the same process with liquid 3. So this is not a perfect method, but this is a fast method. This thing is called a separating funnel. It looks like a balloon with a tap at the bottom, and obviously there's a lid because sometimes liquids will evaporate. We don't want that, so there's usually a lid at the top. We don't want the liquids to evaporate. So you can use it if you have 2 or 3 liquids that don't mix together. So separating funnel is used there. Very few questions on this in the past papers, so not really that important. One more method that I want to do today before we move on to distillation in the next class. And that method is chromatography. Chromatography is separating stuff based on color. And more than just separation, in O levels, we just talk about paper chromatography. Remember, paper chromatography is not a separating technique, it's an identification technique. Because you just identify what is in there, you don't separate them. You are not able to extract it. So extraction wala part nahi hota, just separation ho jati hai. ठीक है? So how does chromatography work? So the first thing, why we're able to separate stuff based on this? Because they differ in solubility. If 2 things don't differ in solubility, you can't do chromatography on that. And obviously, color is used, but it's not that important. Color का भी solution होता है हमारे पास. अच्छा, अब देखते हैं chromatography होती कैसे है. First thing that we have to do, we take a piece of paper. Okay. We draw a line on it, which is our starting point. Chromatography is basically, remember, it's a race between different things based on solubility. So this is a starting point, jahan se wo race start hogi. So this is called baseline. And it is always with pencil. Make sure that if you're writing about it, mention that you're using a pencil. Why? Because we want something that doesn't dissolve. There is no solvent that you use in O levels that will dissolve a pencil, because pencil has graphite in it. Then we are going to put whatever we want to separate on it. And it's usually a good idea to put the pure thing there as well. So let's suppose I want to see if this is medicine A, and I want to check if it has chemical 1 or chemical 2 in it. So that is medicine A. I put medicine A, so which is impure. So this is impure. And these two are pure. Okay, so I've put the pure things in there. So far, what have we done? We have drawn a baseline and we have put samples of impure and pure things on the baseline. The spots are there. Third step, put all of this in a solvent and make sure solvent is below baseline. क्यों? अगर बेसलाइन से ऊपर चला गया तो बेसलाइन हर चीज डिसॉल्व करके पानी के अंदर मिक्स हो जाएगी. पानी है या प्रोपेनोन है या अल्कोहल है, whatever solvent you have. Make sure that the level is below the baseline. Okay. Now wait. क्या होगा? The paper is going to absorb the solvent. The solvent is going to move up, and as it moves up, so it's going to absorb A, it's going to absorb C1 and C2. It's going to push them forward. So let's suppose after a while, the solvent comes up to this level and stops. This is called solvent front. Okay. And the impure thing is going to give us multiple spots. Remember, हमने पहले lesson में बात की थी कि pure things give us one spot, and this thing will give us pure spot. So let's suppose we get spots like this. Now, how do we know what is in A? There are two ways to do that. One is called RF value, and one is horizontal line test. But they're both kind of similar. The main idea is that things that are the same will travel the same distance. So if I draw a horizontal line, so let's suppose I draw a horizontal line here. Chemical 2 and this spot is on the same level. So they are the same thing. So the principle on which chromatography is based is same substances reach same level. That is the main defining principle of chromatography. So I draw a horizontal line, they have the same distance. So we will determine that A has C2. That's what we'll say. We won't say that A has only C2, because A के अंदर और भी तो चीजें हैं, एक ये spot है, एक ये spot है. But A definitely has C2 because it's on the same level. It doesn't have C1 because C1 के level पे तो वहां पे कुछ है ही नहीं. So if you draw a horizontal line or C1, तो कुछ भी नहीं है वहां पे. Okay. That is horizontal line test. If you do RF value, तो उसका क्या तरीका है? You pick, अच्छा भाई, कितनी दूर आया ये chemical. So this chemical has reached this much. Okay. और solvent कितनी दूर गया है? यहां से यहां तक. RF value क्या है? RF value is a ratio, a percentage, a way of knowing कि total इतना जा सकते थे, solvent front तक जा सकते थे, बीच में कहां पे रुक गया. So if I say the RF value is 20%, that means it has traveled 20% of the total distance. If I say RF value is 0.2, it means the same thing. So what is RF value? It is the distance traveled, distance of spot from the starting line compared to distance of solvent front. from the starting line. That's it. So because of this, that same substances reach same level, we can also say that they have the same RF value. So I calculate the RF value of C2, I calculate the RF value of this spot in A, I will know that they have the same RF value. A has C2. One last thing. What if we don't get a color? What if we don't see a spot? If we say there is no visible spot, then the answer is use locating agent. Locating agent क्या होते हैं? These are chemicals that react with that thing to give a color. They can be an oxidizing agent. They can be a dissolving agent. They can be uh, an agent that makes it pop out, basically. It can simply be a color spray. So the locating agent basically is something that makes something invisible visible by reacting with it. So अगर आपको नजर नहीं आ रहा कि यहाँ पे कोई spot है या नहीं है, it's invisible, it is colorless, then use a locating agent. And one option is, so ninhydrin is basically a name of these things, but you don't have to write that, because remember ninhydrin is sold by a company and in O levels they prefer कि आप किसी company के products का नाम ना लें. ठीक है, so आपने water लिखना है, आप pure life नहीं लिखेंगे. Just like that, you just use locating agent, don't write ninhydrin, but it's fine if you do. Similarly, if you have a spot didn't move, what do you do in that case? This means substance is insoluble. So what do we do?
सर
Use a
लोकेटिंग एजेंट की कौन सी एग्जांपल दे सकते हैं?
locating agent का क्या?
एज इन कौन सा लोकेटिंग एजेंट यूज कर सकते हैं?
कोई भी यूज कर सकते हैं, because it depends on the chemical. For example, in the tests of aspirin, people use KMNO4. अब हर बार तो KMNO4 नहीं हो सकता. There is a locating agent, lithium aluminium hydroborate. That locating agent, sorry, lithium aluminium hydride. That locating agent is explosive if you're working with water. So locating agents vary depending on what substances you're using. So in O levels, you just write locating agent. You don't name it. Okay. So two situations where the examiner tries to trap you. One is they say there is no visible spot, and one is they say the spot didn't move at all. So in both of them, we will see we know that if there is no visible spot, we can simply resolve that using a locating agent. And if the spot didn't move, then that means the substance is insoluble. We will need to use a different solvent. Yes, then we can just write locating agent. So chromatography design questions are usually for 4 marks, and the 4 important things you have to mention. You have to mention that you draw a baseline with pencil. You have to mention that you put the solvent below the baseline. You have to mention the definition of RF value, that calculate the RF value of the spot, and things that have the same RF value are the same. And lastly, if you have invisible or colorless spots, use locating agent. So I'll put a star next to these 4 things that are super important. Showing where the baseline is, showing where the solvent level is, identifying the RF value, giving a formula for it or something, and what do we do if there is colorless spot. So visible or colorless. Colorless is the term that they prefer in O levels. Okay. And that is chromatography, paper chromatography for you. We will start with the last technique that we have, which is super important as far as industry is concerned. We will do that in the next class. You do have a test on the techniques that we have studied, all of them, on Saturday, and you have a test on states of matter on Friday. Just to tell you how I take tests. So first of all, I 100% trust you that you will make sure कि आप खुद ही से कर रहे हैं and you're not taking outside help. Okay, that's the first thing. I trust you with that. If you want to break that trust, that's on you. मुझे मसला नहीं है उसके साथ. Second, Uh, you will have 24 hours to do the test. You can open it anytime you want. Just make sure at the end of the test, you tell me how much time it took you to do that. So let's suppose you did a test in 24 minutes and the test given time was 35 minutes. Just mention 24 minutes. Okay. So you can open it anytime you want in that 24 hours and you can just solve it and make sure you time yourself. All right. Good luck. So the first test tomorrow on states of matter and the second test on techniques that we have learned on Saturday. I look forward to checking those and I hope you guys score well.